Okay, so this is chemistry. I'll continue where I ended last time, and organic chemistry. So today I want to look at the physical properties of carboxylic acid. These are the properties, which is the physical properties of carboxylic acid. Number one, since there's a word acid, so it means this is same as the properties of acid, right? Yes. So all acids, they turn blue, litmus paper red. Together. So, and this one is I didn't test for acid. So if one tests an acid, so acid in fact it turn blue, litmus paper red. Right? The number two, they have a pH. pH stands for potential hydrogen. Yes. The pH values less than 7. So anything that contains the pH value less than 7 is an acid. Yes. Apart from that, they have a sour taste. So all acid, including carboxylic acid, even strong acid, they have got a sour taste. So these are the physical properties of acid. Then now I'll go to the chemical properties of carboxylic acid. Okay. So chemical properties of carboxylic acid. So number one, they react with reactive metals to form a salt and hydrogen gas. Yes. So I'm saying that when you get acid, so acid plus metal, which is a reactive metal together, the product is what? The salt plus what? Plus hydrogen gas. Yes. So it means when acid reacts with metal, the product is salt and hydrogen gas. Now, for example of acid. So I'll be using this concept, same concept which is maple B formed here. This one is there in the previous video. So since I'm talking about acid, so acids always start from 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the formula for the acid, the general formula for acid given by the formula is CnH2n plus 1 COOH like this altogether. Yes. So now I'll pick an acid. So I'll pick the one which is on number 2, which is ethanoic acid. So the formula for ethanoic acid, so acid I'll get ethanoic. So ethanoic acid plus metal, I'll get a sodium which is Na altogether. Then the salt. Now, what's the name of the salt? So this acid, ethanoic acid, how can I write the formula for ethanoic acid? So ethanoic acid is number what? 0 to number 1 altogether. Yes. Which means I'll put a 1 here. So it means the formula for ethanoic acid is given by C1 H 2 times 1 is 2 plus 1 3. Then COOH like this altogether. Good. So now, the formula for ethanoic acid is CH3COOH like this. Then plus sodium. So I said you get the what? You get the reactive metal. So a reactive metal here, I can get a sodium. So why reactive metal? Because there is hydrogen, this hydrogen now together. So this hydrogen need to be replaced. This hydrogen to be replaced. So when you follow the reactivity series, all metals that are above hydrogen on that reactivity series, they can react with these acids altogether. So now, since this hydrogen to be replaced by sodium altogether, so it means here the product. Now, what's the name of the product? So the name of the product, when pronouncing when calling the name, you start with sodium. So the name will be sodium. This ethanoic acid, so it will be sodium ethanoid. So sodium ether. Okay, I can remove this. Sodium ether. So at the end you say ethanoid like this. You just put ethanoid. You remove this IC altogether. Yes. You put ATE. So it's sodium ethanoid altogether. Yes. So if it was a propan, it will be sodium propanoid. If it's butanol, to be sodium butanoate. All together?
Okay.
So now, how do you come up with the formula? So this hydrogen will be replaced. So which means, but when you're writing the formula, you start with what? With the acid there. So you see acid CH3COO. This hydrogen is being replaced so by sodium. Then now plus this aqua. Sorry for this aqua side. Yes. Then plus what? Plus hydrogen gas like that. All together. So in short, we're saying that acids, they react with the reactive metals to form a salt and the hydrogen gas. So this is what we're talking about here, which is what? A sodium ethanoate. So it means it can even react with propane. So it will be a sodium propanol, even with aluminium. So it will be aluminium. So aluminium propanoid. We can get any element provided it is a reactive. Altogether,
yes.
Even potassium to be potassium propanoid. Clear? Good. So I'll start to explain this this equation. So they react with the reactive metals to form salt and the hydrogen gas. Don't forget this reaction. Sometimes they can confuse you. They can just say, they can put the element here, which is sodium and acid, then they'll tell you to complete the equation, right? Good. So now I'll go to part B. But the formula will not remove it. Which next part? This part. They react with bases to form salt and water. So it means you can say a base plus acid, or you can say acid,
yes.
Acid, which is organic acid, plus the base. They say the product is what? To form salt, the salt plus what? And water. Only all together. So example with base. You can get sodium hydroxide, for example, a base sodium hydroxide. So acid, I'll pick the same acid which is ethanoic acid for ease demonstration.
Yes.
All together. So ethanoic acid is what? Is CH3COO, like this, all together.
Yes.
Then plus base, I'll get sodium hydroxide, like this, all together. Then plus the salt now, it will be sodium ethanol. So it will be sodium. So I'll start with ethanoate. So this COO like this, COO like this, then sodium, then plus this one replaced by this one. So this one will react with hydroxy. Why? So it will be plus water. So this will come up with the equation. So you need to know that when acid react with base, the product is salt, which is sodium ethanoate. All together?
Yes.
Plus water. Then I'll go to the third point here. The third point, which is they react with carbonates and hydrogen carbonate. So it means acids react with carbonate. Example, we can say acid, the same acid which is sodium, which is the ethanoic acid, COOH, plus carbonate, we can say sodium carbonate, sodium carbonate, like this all together. Then the product is the salt, so this one will react with this guy. So to be what? It will be CH3OO, then we put sodium. Then plus they said carbon dioxide and what? And water. So plus water plus carbon dioxide. So don't forget. So when organic acid react with carbonate, so it can even sodium hydrogen carbonate. So even if you put sodium hydrogen carbonate here, the product will still remain the same. So acid react with carbonate or hydrogen carbonate to form salt, water, and carbon dioxide. So if I put propanoic acid here, so to be propanoic acid plus sodium carbonate is equal to a sodium propanoid plus the same product. If I put potassium here, which means to be this, this is a propanoic acid plus potassium, it will be potassium propanoid plus water plus carbon dioxide. Clear?
Yes.
Okay. So this one is clear as well, right? Then now I'll go to the last equation now here. The last equation, which is it? The last part. They react with alcohols to form esters. This one is crucial now. So the last point is on this one. They react with alcohols to form esters. So it means we're saying that when acid react with alcohol, the product is ester, and the reaction we call it esterification. So the process by which ester is a compound formed when acid react with alcohol, and the reaction is called esterification. It's called esterification. So I'm saying that the product formed when acid react with alcohol is called esters, and also water is also formed here. So the major product is ester. Then the minor product is water. So don't forget, sometimes they can ask you to identify the major product, which is ester, and the minor product, which is the water here. So this reaction we call it esterification. Okay. So now, how do you come up with the equation and the structure here? Apart from that, before I explain the equation and the formulas and everything, first we need to know that during this reaction, sulfuric acid is used as a catalyst to speed up the chemical reaction. And apart from that, sometimes they can ask you to define ester. So ester, as I said, is a compound formed when alcohol reacts with acid. Or if one can say an ester, these are sweet-smelling compounds. Okay? So since esters, these are sweet-smelling compounds, what are the uses of esters? So, number one, they are used in perfumes due to sweet fruit smells. Apart from that, they are also used in food and drink flavoring and also preservation here, to preserve food. So to preserve food, preservation here, preservation. Okay, so to preserve food. Okay, so now let me now explain how esters are formed. So I'll pick an acid here. I'll say ethanoic acid here, plus alcohol. Maybe I'll say propanol here. Then give us. So now, how do you come up with the product? So the sweet name, don't forget the sweet name comes, the first sweet name comes from alcohol. Then plus the last part comes from acid. So since the alcohol here is propanol, so it means the sweet name will come from alcohol, which is it. So I'll write propyl, that's a sweet name, propyl. So this will be propyl. Then the last part now comes from ethanoic acid. So a propyl ethanoid. So I'll ethanoid like this. So this is alcohol, this is acid. So that sweet name comes from alcohol. So propyl, ethanol. So the last part comes from acid. Don't forget on this one. Then plus the water, like this. Okay. So now, how do you write? How do you draw? Or first, I'll start with the equation first. So the formula for ethanoic acid, it is C1H3COO like this. Then plus for alcohol, so pro is for number. So alcohol starts from 1. So 1, 2, 3. So alcohol is for number 3. So 3 here. Then 2 times 3 is 6 plus 1, 7. Then OH is alcohol. Then now the product. How do you write the product here now? How do you come up with the product? So we need to know that. Alcohol, acid, in fact, it loses this OH. It's being lost. Okay. Then to form water, remember there's water here. Then this alcohol, it only loses what? It loses hydrogen. So in short, I'm saying that acid loses OH. Then alcohol loses hydrogen. So this part now form what we call water. Okay. So now the remaining part is written. So when you're writing, since when pronouncing the word, when calling the name, you start with alcohol. But when you're writing the chemical formula, you start with acid. Okay. So I'll start with acid. So my acid is this one. So I'll write CH3CO. So listen, I've written this. It has ended. Since I've removed this part. So now I'll get now the remaining part. But I need to start with O. So this O I'll put it here. Then I'll write this part now, which is C3H7. So this is a formula for propyl ethanoate. Then plus water like this. Don't forget, I say that when you write the chemical formula, you start with acid. This acid, you write it here. When you end here, then you write this O here, put it here. Then the remaining part put at the end here. Then this name now is the propyl ethanoate plus water there. Then how do you know that this is the propyl ethanoate? So you can say, okay, the first part is alcohol. So this alcohol is on 0, 1, so number 1. So it is ether. It's so as what this ethanol. Okay, ethanoic acid. Then this part now it was number 3. So this is the alcohol. What? This alcohol. So this is number 3, which is propan. So to be propyl ethanoate. Okay. Now how do you draw? Okay, this one I remember I taught in the previous video on how to draw alcohol and also the acid here. Now how do you draw this structure? This structure is drawn like this. Carbon here we have 1. Carbon here we have 1. We have 1 here. Then hydrogen 1, 2, 3. Okay. Then we have this C with how many carbon? With C here, okay? C here with 2 bonds here. Then we have O1 O here, okay? Again, we join like this. So how many carbon are here? 3 carbon, okay? Hydrogen 1, 2, 3, 4, 5, 6, 7. Okay, so this, as you can see, this is a coup. This is the identity for the for ester. So just see a C, double bond here, 1 here. Just know that this is an ester. So this is the structure of combination of alcohol and acid. So the way you draw it, you draw this carbon here and hydrogen 3. Then carbon you draw it here. Then C is of OO here. So 1 carbon if one can put down here, but it's supposed to be double bond here. Then the 1 owner will join in the part for alcohol and the acid. So this O here. Then now you write the remaining part of the fire like that. So this is how you form esters. This is how esters are being formed. Okay. So I'll get another example. So I'll use the propanoic acid. plus butanol here. So the answer will be, the sweet name comes from alcohol, so it will be butyl, okay, propanoid, okay, plus water there, okay. So now, how do I formula for propanoic acid? So propanoic acid on number what? Propanoic acid 0, 1, 2, number 2. So say C2, 2 times 2, 4, plus 1, 5, COOH, okay, plus then butanol is number what? 1, 2, 3, 4. It's number 4, okay? So C4H. Remember, alcohol starts from 1. Then 4 times 2, it is 8, plus 1, 9, then OH. The formula is very simple. This one is going to be lost, OH lost, and also hydrogen lost. So I'll remain with it. But when you write the formula, you start with acid. So acid is C2H5, then CO, this, the remaining part, this one. This OH is being removed. Okay? It has been lost, in fact. So I'll write 1 O, then I'll join this one now. This one's also been lost. So O, then I'll join the alcohol one now. C4H9, then plus O, plus water like this. Okay? Then now, this one drawing is very simple. I will try to draw it just for now. So how many carbon are here? So 1, 2, hydrogen, 1, 2, 3, 4, 5. Functional group, C here, double bond here, then OH like this. Okay? Then plus this is the alcohol. So alcohol you have 1, 2, 3, 4. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. The OH there at the A and the end like this. Then how do you draw this one now? This one, the big ruler, this one. So this one is very simple as well. Just say how many carbon are here? 1, 2, carbon. Hydrogen, 1 here, 2 here, 3 here, 4 here, 5 here, this one. Then carbon, this carbon, this double bond here, and O here, which join this part now. So how many here? 1, 2, 3, 4. Okay? Then now you say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the butyl propanoid. Then plus water. How do you draw water here? Water is the oxygen here, hydrogen like this. Okay, so this is how we come up with ester. Hope it's very clear here. Hope it's very clear here. This is how we come up with ester. Then homework assignment. I want you to differentiate between esterification and neutralization reaction. So I want you to give us the difference between neutralization reaction and esterification. And also the differences and similarities. So differences and similarities. So I want you to tell me the differences and similarities between neutralization reaction and the esterification. Okay. Then once you are done watching this video, please don't forget to inform me so that I give you the example and the exam and exercise.